chapter 7 within section 7.3, and what we're going to be looking at is how to solve systems of equations, but our equations are going to include three variables, x, y, and z. And there's several methods to do this, and we're going to first start off by using a method that is called our row echelon method. Here's what happens when we're solving systems of equations. The number of solutions that we may get. You may get one solution, which means everything is going to work out fine. You're going to get an x, a y, and a z, and so this is your ordered triple. And this is an answer that you would get. And then, of course, you got no solution. So somewhere in the process, you're going to get something like, while you're solving, 0 equals a -3, and then that'll indicate that this is not going to be possible. And then the third thing that's going to happen is getting infinitely many solutions, and when that occurs, again, you lose your variables, but what happens usually is that you get 0 equals 0 while solving, and so that would indicate many solutions. Alright, so here's what we got. It's called a row echelon form. And the form is when you develop a stair-step pattern with a leading coefficient of 1. See, this is a leading coefficient of 1 here, of 1 there, and of 1 here. That's our goal. Especially, we focus on this being a leading coefficient of 1, the very last one.
Mr. O, please call 2680.
If you have your form, then what you can do is you can use back substitution to solve this. So let's go ahead and finish this problem out and find the solutions. Obviously, what we know is that we're going to be finding x, we're going to be finding y, and we're going to be finding z. Well, if you have your equations in row echelon form, it's the stair step here where it goes down like this. And your z is equal to 2, so we know that that's a solution. What we're going to do is go back and put z in then. So y plus 3 times 2 is equal to 5. So y plus 6 is equal to 5. Y must equal -1. All right, so there's our y value. And now what we do is we go back and we put both of them into the top. It would look like this. X minus 2 times -1 plus 3 times 2 is equal to 5, and we solve it. X, this is plus, see, this is plus 2 and a plus 6, so plus 8. Equals 5. All right, so here's what I'm noticing right now is I'm noticing that your equations are slightly different. You have a 9 here, so let me change this to a 9, and then this to a 9, and 9. All right, now we can continue on. So we've got your solution then for x, if you subtract 9 minus 8, so x is equal to 1. So our solution to this equation in an ordered triple is 1, -1, and 2. So this is called row echelon form, and now what we're going to do is I'm going to show you how you get it into this stair step right here. How do you move your equations into the stair step? All right, what we're going to do is it's a process that's called like your elimination method. Okay, and so what I want to do is somehow I want to try to eliminate the x values. Okay, we need to eliminate this x right here, and so that's my first step. And a lot of times what we'll do is we'll label our first step, how we're going to actually get rid of that. And this is goes back to your elimination type method. So right here we're going to eliminate my x in my second equation. So we're going to add equation 1 plus 2. Or add row 1 plus row 2. We can call them rows. So when we do that, your first equation doesn't change, but our second equation does. My second equation now becomes 0x, y, so I just go ahead and I can ignore the 0x, 3z plus 0, so that's 3z, and 9 and -4 is 5. Okay, so there's our first step. I also want to eliminate the 2x, so I can also do, for this step 1 here, is to multiply negative 2 times row 1 and add it to row 3. But what that's going to do is that's going to eliminate my 2x. So you're going to use this x to eliminate the x's below it. So negative 2 times x added to 2x is 0. Negative 2, see this is what we're doing here, multiplying by negative 2 and adding. So that's 4 plus negative 5y. Positive 4 plus a negative 5y is negative y. Negative 6 plus 5 is a negative z. And then equals 18 plus the 17 there. And it's negative 18 plus the 17 is negative 1. All right, so we've got our first step completed where the values below your x's are eliminated. Okay, now what we need to do is we need to eliminate, this is my next position here, so this is where we'll go with step 2. We need to eliminate this y. Well, I can do that by adding equation 2 to equation 1. So step 2, row 2 plus row 3. And this is, my first row doesn't change. In fact, it will not change throughout the rest of my problem. And my second row now is not changing because I'm trying to eliminate values in the third row. I'm going to add these together. So add the y's, you get 0y. Add the z's, you get 2z. And add the 5 and negative 1, and you get 4. All right, your last step would be to take row 3 and divide it by 2. And the reason why we do that is so that you get the coefficient of 1. So we're going to go x minus 2y minus 3z equals 9. And y plus 3z equals 5. And z would equal, if you divide by 2, 2. All right, now here's what you're going to see. This is actually the equation that we had just solved in the system of equations above. So that's the position that you want to get your equations in. You want to get it into what's called, this is called row echelon. And if you can do that, then you can use back substitution to get your final answer. And we already had done that from the steps above. We know that our answer is 1, negative 1, 2. All right, that's the process of row echelon. Here's another example. So what we're going to do is we're going to use row 1. We're going to use this x to eliminate the x's below it of 2x and 1x. Okay, so in the first step, I'm going to take row 1 and I'm going to multiply it by a negative 2. So negative 2 times row 1, I'm going to add it to row 2. And I'm going to get a new equation, but my first equation stays the same. All right, I take negative 2 times row 1, so negative 2 here, multiply by row 1, and I'm going to add. So that gives me 0x. This is 6 plus negative 1, which is 5y. And this is negative 2 plus negative 2 here would be minus 4z. And negative 2 plus 2 is 0. All right, also in step 1, I'm going to take my coefficient here. And now what I need to do is I need to multiply by a negative 1 and add it to row 3 right here. So negative row 1, add to row 3. And we would get, so that's negative x plus x is 0. 3y plus 2y is 5y. Negative z plus negative 3z is negative 4z. And negative 1 plus negative 1 is negative 2. All right, our next step then, this is now step 2. We are going to try to we're going to use the 5y here to try to eliminate the 5y below it. So we're going to take negative row 2 and add it to row 3. And we'll just see what we get. So your first row doesn't change. Your second row doesn't change. And now our third row is going to be, so you take this times a negative and we're going to add it to the next row. So negative 5y plus 5y is 0y. Negative 4z times negative 1 is, so you add there, you got 0 again. So we've got 0 equals, and negative times 0 is 0 plus negative 2 and negative 2. Well, what this concludes, we lose our variables, and this is not a true statement. So this indicates that there's no solution. No solution for that system. All right, we're going to look at one more problem here in this video, and we're going to use our equations here, but there's one more technique I wanted to show you, and that technique is sometimes you can rearrange your equations. So I'm actually going to move this equation to the top to be x plus y plus z equals negative 3, and then just slide the other ones down. And what this is going to allow me to do is it gives me a coefficient that is easy to work with. And 2x minus 3y plus 2z equals 9. All right, so here's what I'm going to do. Our first step, step number 1, is we're going to go ahead and multiply the first equation by negative 4 and add it to the second. The first equation will not change. So that's 0x, negative 3y, negative 7z, and 12 plus 11 would be 23. All right, now what we're going to do is we're going to come back and we're going to multiply that first equation by negative 2 and add it to the third. So here what we've got is negative 2 row 1 add to row 2, and we've got, or I'm sorry, that was negative 4, and then we had negative 2 row 1 add to row 3. Here's our results. You get 0x, negative 5y, negative 2z plus z, negative 2z plus the z's there is 0z. I'm going to go ahead and leave a space there for 0z. And finally here what we've got is, what's the other side? So you've got 6 plus 9, which is 15. Well, this might not be an exact stair step that we would like to see. However, you can solve for y here. And so our last step is going to be to take row 3 and divide it by negative 5. Here's what we've got. I've got y is equal to negative 3. Now it's not ideal to have your stair step look like that, but it is enough information for us to solve. So we know our y is negative 3. Now what we're going to do is we're going to take our information and we're going to back substitute. We're going to put the y in. All right, so we know y is equal to negative 3. Now what we're going to do is we're going to find our z. So z would be negative 3 times negative 3 minus 7z equals 23. This is 9 minus 7z equals 23. If I subtract 9, negative 7z equals, something happened with my my 23 here. Hold on one second. Okay, we're okay. So 23 minus 9 is 14. And so z would equal a negative 2. Now our last step is going to then come back up to the equation number 1 and substitute. So to find x, we do x, and this is y, so minus 3 plus z, so minus 2 equals negative 3. So this is x minus 5 equals negative 3. So x is going to equal 2. And there you have our solution. And I strongly recommend that you write your solution in a triple, 2, negative 3, negative 2, final answer. And there you have it. In the next video, we're going to look at how to solve when you get many solutions.